Hello and welcome to another ER and relational model video. In this video we're going to have a look at relationships within a relational model. In our previous video we looked at how we can model attributes within a relational model, and now we're going to take a look at how we can translate relationships within an ER diagram into a relational model. Let's first have a look at an example ER diagram. We have a student and course relationship here. The cardinality here is a 1-to-1 with both arrows on both sides. And we have a partial participation. Both the student and the course have one attribute each, with the student having a ZID and the course having a course code. Now to represent this as a relational model, let's first translate both entity sets into a relation. So for the student, we'd get student and ZID down here with a box around it. And for the course, let's write it over here. And let's put down our course code. I'm just going to put down code. And let's put a box around it. Let's also underline these to signify that they are the primary key of their respective relation. Now let's think about how we can model relationships within a relation. For an ER diagram, it's really easy. We just use a different shape and arrows to signify the cardinality. But we have to kind of bake that in to our relations without having that sort of visual aspect. So let's look at a few instances. So we have student with ZID 1, student ZID 2, and then course maybe 1917 and 1927. How can I model the fact that only one student will take one course if we just have a series of entries? It turns out the way we do this is by using the primary key of another relation. For example, if I, right next to ZID number 1, put down 1917, and in my relation I signify code over here, and I know that this code belongs to this relation over here, so I know that it's not part of the student relation, then from this I can understand that what this is saying is that ZID student is taking the course 1917. And in fact, this is how we do it. And when we use a key in a relation that it doesn't belong to, we refer to it as a foreign key, and we put an arrow towards where it belongs to. So in this case, this code key belongs to this course relation. And so when we have a key in a relation that it doesn't belong to, we call this a foreign key. A foreign key. So I've spelled it horribly wrong. Foreign key. And it's the same with student 2. So we can signify that he also does 1917, and student 3, maybe she does 1927. Now, since only one student can take one course, and a course can only have one student, in effect, doesn't matter where we put this, a key. So we can not only put the code over here, so you can remove this and remove this as well. We can also just put the primary key of student in course because it's a one-to-one relation. So ZID over here, and once again we can add an arrow. And then for 1917, we can say the student in 1917 is 1, or ZID 1, because we have a one-to-one relationship. Now this becomes a little more obvious when we look at other relationships. So let's have a look at a one-to-many relationship. So using the technique we've learned with foreign keys, let's first draw out our relations. So we have student again with ZID. Let's draw a box around it. And we have course with course code. Let's draw another box around it. Okay, which foreign key do we use, and in which relation do we put it in? Let's take, for example, let's try putting the ZID of student in course. So ZID over here, and let's draw an arrow, and this belongs over here. Let's look at a few examples. So we know that student 1 over here and student 2, and we have 1917, which may have a student 1 enrolled in it. And let's say student 2 also enrolls in 1917, so 1917 with student 2. And let's go again, 1917, student 3, and so on and so forth. What about if 1927 didn't have a student? What if no one's enrolled in 1927, then we'd have an empty key. So this would be empty. Now imagine if course had more than one attribute. It had course name, maybe semester, maybe a timetable as well. For every single entry for different ZID, we'd have to copy and paste all those entries as well. So we're going to have a lot of duplicate entries. And not only that, we're going to have a lot of empty entries as well. So we have a lot of redundant data. So this is not optimal. We don't want this in our database. We don't want redundant data, and we don't want a lot of empty entries as well. Okay, so that way won't work. Let's try putting the foreign key in student this time. So let's get rid of this and get rid of these examples. So let's put the foreign key in student, and in this case, it will be the code. Does this way work? Well, suppose we have a student 1 enrolls in 1917. That works well. And because only a student can enroll in only one course, we know that we're not going to get another entry with ZID1. And let's go number 2. And they also enroll in 1917, so that's fine. And student number 3 also enrolls in 1917, and that's also fine. We're not going to get duplicate entries for number 3 because our relation shares only one many to one. And we don't have that empty entry problem like before with 1927. We just don't have any entries in here that have 19127, and we won't get any duplicate data as much. The only duplication we have is this, but that's only one attribute we're duplicating versus an entire row of data. So this is the correct model. So for many-to-one relationship, we add the foreign key to the entity set, which has the many cardinality. So in this case, the student. Finally, let's have a look at the many-to-many relationship. Again, let's draw out student with ZID. And let's draw out course with the course code. Now, because we have the many-to-many relationship, if we do add the course code over here, like before, we're gonna encounter a problem we didn't have from before. So ZID1 enrolls in 1917. So let's say 1917 is over here, and 1927. So in our previous example, because we had many to one, we knew that if student 1 enrolled in 1917, that's the only course they enroll in. But in this case, a student can enroll in 1917, and student 1 can enroll in 1927. So we have a duplicate entry. And if the student had more than one attribute, we'd have to duplicate the entire row and just change one field. So this is not optimal. And if we add the foreign key over here, again, we encounter the same problem. So what can we do in this case? So for a many-to-many relationship, what we do instead is we create a brand new relation out of the relationship. So we create a third relationship. Let's call this course taken. And we add the primary keys of both student and course in this third relation. Only those two. So not the rest of the attributes, just those two attributes we add. So let's remove this code. And let's go ahead and put down ZID over here and code it in here. If there's any attributes on the relationship in the ER diagram, such as maybe the date, we also add that to the third relation over here. So we'd get a third relation only including the primary keys from student and course. So these will act. So those two are foreign keys, and we can also consider them to be the primary key of course taken. And then we just have arrows from ZID to this and code to that. Oh, sorry, other way around. So ZID points towards this primary key and code points towards this primary key. So now we have student 1 is taking 1917, student 1 is taking 1927, student 1 is taking etc. And we can do that for all the other students as well. We're only duplicating one entry, which is the ZID here, which is much better and more space efficient than duplicating an entire row of data, which could be multiple columns. So those are the three types of relationships we need to worry about when modeling relational models. So we have the one-to-one, where it doesn't matter where you put the foreign key. One-to-many, where you put the foreign key on the side which has the many. And finally, a many-to-many, where you create a new relation and add both primary keys into the relation plus in your attributes. The attributes for the rest of the examples also go where the foreign key goes. And that's it for this video. Thank you very much.